So the next topic in your module 2 is the three different configurations of your BJT. Okay, so the three different configurations are configurations of your bipolar junction transistor. One is called as your common emitter configuration. Second one is called as your common base configuration. And the last one is called as your common collector configuration. Okay. So in the case of common emitter configuration, you have the emitter to be grounded. Okay. So the emitter will be grounded and it will be common to both your input and your output. So what is your input in the case of common emitter configuration? Base is going to be the input and the output is going to be your collector. Okay. So here, since the arrow mark is not pointing towards, it is NPN transistor. So across the input side, you have to forward bias, right? If it has to act as an amplifier. So here it is P. So P should be connected to your P. So this is going to be a forward bias condition of your input side. And across the output, you are going to give a reverse bias condition. So it is opposite polarity. Here it is N. So the opposite P type is being connected. So your N will be connected to your P of your battery. So since this is your base, we will give this as your supply voltage VBB and this is going to be your supply VCC. Okay. So this is a common diagram of your common emitter configuration. So what will happen to your common base configuration? So the base will be grounded. It will be common to both your input side as well as your output side. So in this case, what is going to be your input? Input is going to be your emitter and the output is going to be your collector. So how can we identify? By an arrow mark. Okay. So in this case, we will give the flow of currents also. Here it is IE, IC and IB. It flows towards your emitter. So here also we will give the flow of current IE towards the emitter IC and here it is going towards. So it is IB. Okay. So in this case also the input will be forward bias NPN. So N will be connected to negative. Okay. And this is your forward bias condition, and in the case of the reverse bias, output side should be reverse bias. So here it is again N, right? Collector side it is N, so it should be connected to your positive of the battery. So this is your diagram of your common base configuration. The supply here is VEE and here it is VCC. Similarly, common collector configuration. So opposite to that of your common emitter will be your common collector configuration. Just reverse your transistor. So your collector is going to be grounded, or it is common to both your input side as well as your output side. So what is going to be your input side? In the case of common collector configuration, input will be your base and the output will be your emitter. Okay, so collector is grounded. So let us give your arrow mark not pointing towards. So again it is NPN type. Okay, so what will be your current flow? Current flow towards your emitter, right? So IE, IC and this will be your IB. So input side is again forward biased. So here it is NPN, positive. So positive will be connected to positive of the battery. So here your supply is equal to VBB since it is base, and the output side should be reverse bias. So here it is N, right? NPN. So your emitter is N. Reverse bias means N will be connected to your positive. So this will be your basic three diagrams of your common emitter, common base and common collector configuration. Okay. Now let us draw your input and output characteristics. So in the case of common emitter configuration, what is meant by your input characteristics? A graph which is plotted between your input parameters. So in this case, your input parameters are your input current and your input voltage. Okay. So in this case, your input current is equal to your IB and your input voltage is equal to between your base and emitter. So it is going to be your VBE. Input voltage Keeping what as constant, output voltage as constant. So the output voltage is equal to your collector emitter voltage VCE. So it is equivalent to that of your PN junction diode characteristics. After the cut-in voltages, your current increases. So in this case, VCE, if I can take it as 0 volt, VC is equal to 1 volt and VC is equal to 2 volt. That is in the case of CE configuration, your waveforms will be pointing outwards. So this will be the value for VE greater than 0. When VCE is greater than 0, your graph will be following outwards. This is due to the early effect. Okay. And what about your output characteristics? A graph which is, so this is your input characteristics, and your output characteristics will be your graph which is plotted between your output parameters, keeping input as constant. So what are your output parameters here? In this case, output current is equal to your current IC, and your output voltage is equal to your VCE voltage, right? Collector to emitter voltage. Since it is a current control device, the output current will be controlled by the input current. So in this case, it is IB, right? Input current, keeping IB as constant. So in this case, you will be having your output characteristics will be having three different regions. One is called as your, this region where you have IC is equal to 0 will be your cutoff region, and this region will be your saturation region, and this region is going to be your active region. Okay, so keeping what as constant, IB is equal to 0 microampere, IB is equal to 10 microampere. As IB increases, the current IC also increases. 20 microampere, IB is equal to 30 microampere, IB is equal to 40 microampere, it goes on. What will be a unit of IC? Milliampere. Since base is very small, you will have your unit as microampere, and the voltage unit is volt. Here also it is volt. Here, since it is IB, it is microampere. Okay. Now let's see the input, and so this is your input and output characteristics of your common emitter configuration. Now what will be your input characteristics of your common base configuration? Similarly, your graph is plotted between your input parameters. So in this case, the input parameter is your current IE, and what is your input voltage emitter base? So VBE. Okay, VBE, keeping what as constant? Output voltage as constant. So it is VCB, between collector and base. So this is also equivalent to that of your normal diode. So in this case, the difference between your CE configuration and CB configuration is, so this will be VCB is equal to 0 volt, but as the value of VCB increases, you will be having your graph shifting inwards. So VCB is equal to 1 volt, VCB is equal to 2 volt, 3 volt, etc. Your graph will be shifting inwards. This is also due to your early effect. Okay, so the unit here is volt, and IE is approximately equal to IC, so you will be having it as milliampere. Okay, now what is the output characteristics? The output characteristics is the graph which is plotted between your output parameters. What is your output current? Output current, since it is collector, output current is IC, which is in milliampere. And what is your output voltage? VCB, keeping your input current as constant. So in this case, what is your input current? Input current is equal to IE as constant. So you will be getting your graph in this way. Okay, so IE is equal to 1 milliampere, IE is equal to 2 milliampere, IE is equal to 3 milliampere, it goes on. Okay, so this will be your output characteristics of your, as your VCB increases, your current keeps on increasing. So this is your output characteristics of your common base configuration. Last, let me see what is the output, input and output characteristics of common collector configuration. So in the case of common collector configuration, the input characteristics is plotted between your input parameters, keeping your output voltage as constant. So in this case, the input current is equal to IB, and what is your input voltage, which is equal to common collector is what common. So you will have the input as your base, okay, and keeping your output voltage as constant. As your VCB increases, your current IB decreases, okay. So this will be your graph of your VC is equal to 1 volt, 2 volt, etc. Now what will be your output characteristics? The output characteristics of your common collector configuration is plotted between your output parameters. So what will be your output parameters? The output current is IE in milliampere, keeping your output voltage as constant. Your common collector it is, so your output is VCE. Keeping your input current as constant. So what will be your input current? IB, right? So since you know that IE is approximately equal to IC, it will be similar to that, mostly equal to that of your common emitter configuration. So you will be getting the output characteristics with 3 different regions. Again, it will be cutoff region. This is going to be your saturation region, and your middle part is going to be your active region. So let me write it. IB is equal to 0 microampere, IB is equal to 10 microampere, IB is equal to 20 microampere, 30 microampere, 40 microampere, 50 microampere, it goes on, okay. So these are the different configuration. Now you have one more factor that is called as your current gain. So in the case of common emitter configuration, you have the gain as your beta. Beta is equal to, always your gain is equal to output divided by your input, right? Since it is a current gain, beta is equal to output current divided by your input current. So what will be your beta? In the case of common emitter configuration, what is your output current? Emitter is common, your collector is your output. So output current will be IC and the input current is going to be your IB. So beta is equal to IC divided by beta. In the case of common base configuration, again you apply the same formula. Your current gain is taken as alpha. Alpha is equal to output current divided by input current. In the case of common base configuration, emitter is your input, collector is your output. So what will be your output current will be IC and your input current will be IE. So alpha is equal to IC divided by IE. And in the case of common collector configuration, the current gain is taken as gamma. Gamma is again equal to output current divided by your input current. So in this case, what in CC configuration, what is your output current? Output current is equal to IE divided by what is your input current? It is your IB. So these are the 3 different current gains. Now you have your relationship between alpha and beta as alpha is equal to beta divided by 1 plus beta, and beta is equal to alpha divided by 1 minus alpha. These are the important formulas which you can refer for doing your problems.